Okay, I think it's kind of live on YouTube. I gotta adjust a couple of things still and pull up the chat. Get started at 10:45. The chat up for YouTube. Need one for Zoom though. Cool, I got both live chats open. I need to tell the Discord now, and then I also need to post a link to it over here so you guys have that. There's the invite link for the Discord. We've had community issues in the past, kind of. So I don't just like kind of leave it out, leave out unexpiring links anymore. But so that's the link to join. It's good for about 24 hours. I still need to actually tell the Discord channel itself that I'm live. Right, 1 minute here. Right, I've got everything set up now, I think. Cool. We're gonna have like 8 to 13 different approaches on this. Give me a minute to grab some other things. I'm still setting up my I have notes for this. That's the only way I'm gonna remember to do all 8 to 13 different approaches that I have planned. It was 11, actually, yeah, it was 11, my bad. But yeah, so that's how I remember all 11 approaches. I don't just pull them off the top of my head. So I'm gonna set up a couple of things, but I'll see you guys at 10:45 p.m. PST. Okay, I can at least start listing off the approaches. I'm not really going to say that I'm kicking this off really for another few minutes, but I can at least start listing off the approaches. Well, machine. All right, I got shard PostgreSQL. I item ID got OLAP. Got two different OLAP ones. I'm also covering real-time use cases. So that would be, I got Flink slash Firehose. Those are the min count sketch thingies. We got Redis TRDTs. So this one is without doing without the sharded counter. It's I tried to do it at progressively higher scales. I got a complaint, one of my other problems, that hotel booking, or it was like for a couple of the problems, like I just design it for way higher of a scale than it really needs to be. And so like I mean, the first thing you should do with your interviewers is clarify what the scale is, and you might just need a single PostgreSQL machine, and that would probably be fine. You might not even care about accuracy. So I should even probably clarify like ways that it can vary. What would I call that? Variations of the problem. So it's scale, and so that it's like just overall scale, and then you'd have proportionally reads versus writes. And then also it's latency expectations and accuracy, precision expectations. So then that's where, you know, CRDT versus sharded counter. So for example, with read scale versus write scale combined with latency expectations, that could be is OLAP slash map reduce an option. And then, oh, there's real-time rolling window versus so that's like a rate limiter for top K. So rate limiter slash top K versus what is it? All-time aggregate, which is shoot, which problem is that? Oh, flash sale or inventory, for an example. So like these would be like count min sketch, for example, versus just sharded counter kind of thing. 7, get full bloom filters. I don't know if I'm actually going to draw out a couple of these, like the forgetful bloom filter is just an alternative type of CRDT versus a grow counter. And then we got 8 is sharded counter. And then there's there's a sharded counter on its own is non-item potent. So then you would need sharded counter with is it sharded counter plus request table for item potency. And on its own, then we got what, 10. Do just the request table with event sourcing and just do full table scans. That's like the map reduce approach. So this might be redundant with 2 or 3. Oh, I see a couple comments. So part of YouTube's live chat is the 200 character limit. Oh, that's unfortunate. Oh, did you have a long message? If you just drop it on Discord, I'll read it and just tell me. Well, the Zoom call does not have a character limit. Somebody was dropping in messages during the web app, during the weather app problem coverage that were like 1,000 characters long. So if you want to post a really long message, the Zoom call is the best way to do that. Yeah. Okay. 10. Just request table. What is it? It's like a map reduce thing. And then we have, oh yeah, my inventory videos coverage. And so I had a workaround. It's let me try to explain that. Just like DynamoDB doesn't handle multiple tables very well, so I had a trick for denormalizing request table a little bit. Into the counter table. I have a web. Okay, so this one was no materialized view of 4. This was, oh, okay. I see. I kind of do have these broken down a bit. So it's like 1 and 2 or 1 approach. And then we have these ones are rolling window time range counters. And we had all time counts, no rolling window, no super hotkeys, which is the sharded counter one. And then you have feels like starting with 6. Had what did I name it? All time counts and super hotkeys. There. Now all the colors kind of show up properly on this. Okay, nice. All right. Yeah, all right. I guess I can say we're starting. And I have all, well, oh, I didn't explain the OLAP ones properly. What the heck was I doing with this? No, it was between these is actually, so I had one that was a rolling window approach, and the other one was not. This one was no materialized view. And then what in the heck did I have for this one? Counters, no counters, do a full table scan for getting the count. Oh shoot, I even had 3 approaches under 1. Heck. I'm sure. All right, that can work. All right, now I can go ahead and kick it off. All right, so today we are covering the problem of designing a distributed counter. This is actually a real question that they asked in Microsoft interviews. It has actually been asked as a systems design interview question at Microsoft on at least one occasion. I know there's also this one called hit counter. I think Facebook might ask for a distributed hit counter. And then it's a building block concept kind of for a lot of other problems like top K, flash sale, hotel booking even kind of has a counter, inventory, ticket master. So many different problems have some kind of counting thing that's involved in them. So it's like a core, it's almost like a component itself of these so many other larger systems, and you just match it with these other pieces. It's not really covered on its own in any books. Of course, a bunch of different books do cover stuff that builds on top of it. It's just going to boil down to two things: is that you got some kind of endpoint where you're going to take increments of the counter, and then you have some kind of means of reading the count. So it's just kind of like two endpoints that this boils down to. Here's our checklist. There's almost no way that I'm going to get around to everything on that. There's no way I can get around to NALSD estimates on this. I think I had another thing. It was on the tip of my tongue for how to do variations. Oh, item potency. Well, so that's kind of like an aspect of it's kind of like a subpart of accuracy or precision expectations. So there's a bunch of different ways you can vary this problem too. I think this would actually be better put like right under requirements. Yeah, that would be a much better place to put this. Yeah, and then we got all those approaches. I should have just moved checklist all the way to the bottom. There, that's a nice review of what we're planning on doing today. All right, so yeah, it's a common building block in bigger problems, and it is actually even asked on its own. So here's a bunch of different ways that you can vary it under different scenarios. And I've already got 11 different approaches for it. I had 3 sub approaches under one. The first thing you should do in an interview is actually clarify the scale. And sometimes all you need is just that PostgreSQL machine, just like one on its own. So yeah. Any questions before I try to start digging into some diagrams here? All right, I'll go ahead and get started then. Okay, so we're going to start off with 1. So we're of course going to need to do our entry points and exit points, which are 1-to-1 with our requirements. So it's user submitting a hit to the counter. So like, for example, with rate limiter, it would just be like a request. And then we've got a user reading the count. And we're going to have 2 different endpoints for that, CQRS. I mean, in practice, you can, of course, put them on the same machine. That's, I mean, under low scale, you'd probably just have them on the there we go. We're going to have a write coming in. Going to put it into some kind of data store. It's going to be the counter data store. So you're going to write it over there. Then you can, of course, read it off backend. So that's just you send it in, you get your 200 back to the customer. And then for the read, they send in their request. You do a read off the counter, and then you send your response back to the client, 200 OK with count. So that's the basic, most low scale setup, of course. So let's talk about the schema a little bit. So this is approach 1A is just the counters. Yeah, okay, so counter table, and we just have this. You would have some kind of item ID, 4, 5, 6, and then you would have the count of it. So it could be anything up to like it's anything you want it to be. It could be over 9,000. Fun meme reference. Okay, that was kind of cringe. Sorry. 5,678. So we've had 5,678 hits for that item ID. So this is approach 1A, just the counters. This is non-item potent. Just the counter. Can I get it to color properly? Nope. All right. Whatever. So there was 1B, which is the request table. So right now it's not item potent. So this one is non-item potent. And then we're going to have a request table. That is to make it item potent. And then C. Oh, yeah. Okay, so this one is just the request table, which is also item potent, but you're doing full table scans. And these will be we for the rest, all the other approaches are basically just taking these and putting them under higher scales where you have to do partitioning. So it's we got the 3 things that it just kind of boils down to, except for the rolling window approaches. Those ones are just kind of on their own as well. So this is approach 1A, just the counter. Just the counter, and then we're going to do 1B. So we got the counter, and then you would make the modifications by also using a request table for item potency. And so then here you would have just a request ID that you would use for deduping the requests. So we're going to do DEF ABC 1, 2, 3 DEF ABC. And then we don't need to do anything else. We're just having it there, and we do them both. We update both the records in a transaction. So that way you either have this and have incremented, or you have neither. It's either going to do both, or it's going to roll it back. But you would of course also need to have that request ID as part of your request over in so for 1B, you're going to have your request ID over here that you would be sending with it. And then that's not necessary for 1A though. And then for 3, we would just have request table. Just the request table. And so then you would also need to have your item ID with the request. And then you would figure it out. You'd find the count by just doing a full table scan. We can go ahead and fill in some database choices here. This is just for one node, PostgreSQL. It's all with PostgreSQL. But for example, with this one, you might use, if you're scaling it up, you might use Cassandra, you might use Redshift, you might use Trino, some kind of, this is the OLAP. This will scale up into an OLAP use case. While 1B would scale up to sharded PostgreSQL, and 1A, that would probably be, you could do CRDTs, could probably do DynamoDB. Yeah, you know what? That would probably be fun to record. So this one could become Redis CRDTs or Dynamo. I'm going to check the chat here in a second. I just realized I haven't looked at the comments here for a good minute. This one would kind of scale up to manually sharded PostgreSQL. And then this one would become more like Cassandra or OLAP, Trino, Redshift, MapReduce, just OLAP scenarios, data warehouse stuff. Okay. Cool. So that's everything for one, where we're just hosting it on one machine. We're kind of seeing how it's going to shape out to those other approaches down the road. Not covering the rolling window ones. Those are kind of like a whole thing of their own. I guess you would kind of need timestamps to, you'd need to plug in timestamps on the request IDs, and then you would probably still end up doing full table scans in order to do that. Maybe that's what I was doing for 4. Yeah, I don't know. All right. Anything in the chat? I do see at least one item here. Let me look at it. Okay. Is the read browser getting pushes for hits, or is there an implied request? It's implied that it's a request. It was so I didn't draw it out all the way, but you would get a request coming in, and then you do, a request and response against the data store, and then you get the response back to the browser. So it is still pool style, although that is interesting. That is actually a variation I didn't really consider, is push style updates to the count, which is that could be a fun variation in some cases. I'm actually going to record that under variations. I'm not going to try and draw that out today probably, but that would be fun. So that is WebSockets. So you would do something that looks a little bit like what you do for implementing WhatsApp or Facebook Messenger, and you would just have the pushes come straight out off a DB trigger or something. There's like half a dozen different approaches just for getting WebSockets to update off of a database. So yeah, I should definitely not dig into that one today. All right, so we did one. So I did answer that. Is it polling? It's polling. And this one was, yes, there's an implied class. Great questions there. Yeah, thanks for specifying. We can use Postgres for approach 1A, right? Yeah. Yep. 1A through 1C is Postgres. I'm just showing how they would, the arrows are for indicating how they would scale up to multiple machines, like how they're kind of analogous to distributed problems. But yeah, these are all intended to be with PostgreSQL. I mean, you can use something like MySQL as well. There's a variety of different things, but Postgres is like the most popular one for single machine databases with like strict SQL. Okay, let's move on to 2, shard PostgreSQL by item ID. So here, I'm going to go ahead and copy this. Was this, didn't specify whether it was with a request. So this is, I think this is just if it's too much for one machine, but you don't have super hotkeys. So it would be inaccurate. So this is non-item potent. So 2 is non-item potent. So that means lower accuracy. And it's too much write volume for one machine, but you don't have super hotkeys yet. So you don't need this, and then you would have you do have it like sharded out. I guess DynamoDB is probably a great example of like how you would implement it. In this case, is that you just kind of have this kind of like under the hood. Stick this over here, do that, and then do and the schema would be, we would just have this one, and it would be you'd use this one for the partitioning key. And it's also the primary key. You don't need a sort key in this case. And then it would likely be DynamoDB is a pretty good choice for the technology there. Yeah, that one works pretty well there. So that's approach 2. All right, approach 3, OLAP, no materialized view. I think this is where I just have this like request ID table. So, shoot, this one's weird. You might want to even have Kafka in there. Here, I'm going to mark this as approach 2 first. Let's make that extra large. Okay, and then let's take this, copy that for approach 3. Okay, and well, actually, in this case, you do use those. You are using those request IDs because it's getting logged to have this. And then I think you would probably want to use Kafka. So we're saying this would be, for example, you would have high write volume, low read volume, and low latency. No, low. So when I say low latency, that might sound like fast reads, slow read latency expectation. That's how I can communicate that properly. Okay, so that's where you would want this, and then we're gonna have Kafka in there is probably what you would want. It's a data warehouse. And they're not really supposed to be great in terms of availability. So you would probably want to crank up the availability by using Kafka there. Yeah. And you would need something that would read off of Kafka and put it into your data warehouse or OLAP table. Do this. You would pull off of Kafka, curve that, do this, and you would do a write to the counter data store. I'm going to mark this as Kafka, that medium. Actually, we should probably make these large so that you guys can actually see it. Did I make this large? No, I did not. That was a mistake. Sorry if that was hard to read. Okay. And then our table here, it's like from 1C. Go ahead and copy this over to here. And we just have a quest table only. And our technology, Cassandra actually has built-in integration with MapReduce as well as considering it there. Yeah, Trino, it's a data warehouse. It's you run Trino on top of can use something like Parquet files, actually, Parquet files in S3. So you can even do SQL on S3. If you ever heard of that, that's like a built-in feature for S3 buckets is that there's a SQL on S3 thing. And I think it's analogous to Trino. So you're just kind of like dumping stuff into these like HDFS hard disks. BigQuery, which is, so Trino is also similar to BigQuery. So that's kind of what I'm going for here. BigQuery and Trino are pretty similar. Apache Pinot is another one. Another thing for this. there's a lot of different things for this, and like you really don't see them a whole lot in traditional system design interview problems. Like they don't really go over data warehousing, but that's like what the data store becomes in this case is it's OLAP / data warehouse. And yeah, you really do not see this a whole lot in traditional system design interviews. So it's, yeah, kind of important to cover this. So that is approach 3. I'm going to copy this, and then we're going to label this properly like that. Then I'm going to check for any comments in the chat. Yeah, there's our approach 3. There might be a way that you can just go ahead and pop this out and delete it. I have it there for higher availability just because OLAP's not necessarily known for being the best availability. And that's why I think it's a good idea to have it there. All right, let's look at the chat. What's a request table? And somebody said, I think this person answered it properly. Table in a serializable DB that records process, so we don't have to double count the same request. The purpose is to ensure. Yes. Yep, that's correct. Yep. It's so serializable. I think you misspoke there because that sounds like it's for serializable isolation. The intention is purely to dedupe the request ID from the client. So the issue is that when you have a, sure, I can go over this. Let me go ahead and try and draw this. Yeah, so you have them submitting their request over here. They got this request ID. You write it, and you're getting this response back. And so you've already done the increment of your counter or whatever, possibly. And then let's say that you get a dropped operation right there. It doesn't make it to the client. They get a 404, and they're like, oh, I don't think it got read properly, so I need to go ahead and submit a, I think it didn't properly record my increment. And so you resubmit it. And then so you're sending that same exact request ID again over there. And now that it's it should be the same request ID. And you're trying it again against the database. And this time when it returns, so it does the processing, it returns, and now you get a successful response back. So without the request ID, it would not be able to deduplicate that second one. You could get a double count off of it, which is an issue. So the request ID is just some kind of item potency key that you use for deduplicating the counter. And yeah. But I don't think it necessarily has to be serializable. That might have just been like a little typo or something. But I do want to say, yeah, that's correct right there. What do we have here? OLAP approach, it becomes somewhat of a event source. Yes, it is. Yeah, it does become. Did I see that on the approaches? I definitely had the word event sourcing somewhere in my notes. But I like that word. Event sourcing is definitely a good word for that. Oh, 10. Yeah, there it is. Yeah, I do have the word event sourcing in there. How is 3 different than 10? What did I do? What is... I think 3 and 10 were redundant. Okay, whatever. All right, I'm going to move on into other comments. Yeah, I like the word event sourcing. Yes, that is definitely correct. As a quick reminder, I do post the MD files. I upload them to Pastebin. I stick them in a pinned comment. That's why I'm taking my time with these. and actually typing stuff out. I know it's a little slow to watch. In the request table, can't we store the counter too? Well, so it like depends. That could add extra latency in some cases. That's like a trade-off. So in you can't store it directly on the request table because then that would actually require total order broadcast. But you can have it in a second table. So on 1B is kind of where I showed that, is where you have a request table and counter table both. It can shard it by so if you do a manually sharded table, you're also going to have the item ID stored as well in that request table for routing it to the proper co-located shard. So wherever the heck I do that is oh, I forgot that you should also probably have the item ID in here in the request. I think every single case is going to need the item ID. So this one has the request ID, and then you're also going to have the item ID is 456. And we're just going to quickly do 1A has the item ID 456. There we go. So you can do a second table, but having it directly on the request table would require total order broadcast, which is very bad. That cranks up latency a whole bunch. Yeah, interesting idea though. I like, so if you're trying to like count off the requests and like have them like numbered, so like you might have like, for example, a timestamp also in there, and then it would be, instead of you would have like the increment, like so it'd be like you're counting off, so you'd have a record like 5 there, and then you would have some other request ID, same item ID, and then you have 6. So it would look like 6, and then you have some guy that's like ABC, DEF, ABC, DEF, 234. This was what I was imagining that you were talking about. IE, a few minutes. I'm going to delete this from that diagram so that it's back the way it was. But that's what I imagined that you meant. And that would require total order broadcast for sure, which is you'd prefer to avoid that. I did that right, didn't I? Yes. Okay. There's a lot in the Zoom chat. Use Postgres for 1A. How count will be aggregated in case of sharded solution? Yeah, it would be a key range query. So it'd be a key range query. But it'd be limited because it's you still have a part of the partitioning key, so it's not as bad. So if you didn't have it as part of the partitioning key, it would be really bad, and that's where you're hosing all the partitions, like we've seen in some of the other problems. It's really crucial that you have something part of the your primary key remains in that thing for when you're doing a sharded counter. Yeah. So it shouldn't be bad. It's really good that you caught on to that though. Okay, no materialized view. So God, please copy. So a materialized view is where that's more of a thing from OLAP databases. Where in the heck did I actually use that term? Was it in one of my approaches? I might not even know what I was talking about with that. Yeah, okay, so no materialized view just means that you don't have a counter stored. A materialized view is like you can have this in SQL, you can create a virtual table, I think is what it's called. PostgreSQL supports this. It's like a very old school 90s thing of having this like materialized view where it's just like this table, but it's not like really what you're writing. It's just a thing that automatically updates when you update the other tables. It's from like normalized SQL land where you have like 50 different tables in the same database and they have a whole bunch of foreign keys and stuff. A materialized view is a thing that just pre-aggregates stuff for you into a thing. And so like counters would be like an example of a thing that you would have in a materialized view. So you would just have this like request ID, you would just have like the request table, and then you create the counter table as a materialized view. And then instead of having your transactions manually update the counter table, it would go ahead and like update that table for you. So it's basically like a second table that's updated with DB triggers. And aggregates the counts for you. Yeah, that's kind of what I'll describe it as. But it's from old school SQL land. Yeah, I don't know if there's another way to describe it. It's very common in OLAP though. I think it still is pretty common in OLAP. But you don't really see it a whole lot because that's like back in the data warehouse, and it's very rare to get opportunities to do hands-on stuff with OLAP databases. I'd imagine Snowflake probably has a lot of stuff with materialized views that like goes on under the hood or something, or ClickHouse probably has something like that. But it's like if you have ever taken a class on making normalized SQL databases with PostgreSQL, where you have like 50 tables and foreign keys. If you like look into your textbook, like into like the advanced section, you'd see stuff like that, and also like performance tuning, but it's like stuff intended for like a single machine, like one database on one machine, and not like it's weird. Yeah. Okay, I'm gonna keep moving on, but I think that probably handles that. And for a variation, okay, I'm going to go through this. It didn't copyright. There we go. What have we got here? For a variation, what if we want to include multiple views by one person as multiple hits? So you would use different request IDs. If you want it to be idempotent, otherwise you would just have, if you're not doing idempotency keys, then you would just go ahead and let them submit multiple requests, and you would just of course not have accurate numbers for it. I look at post ABC, scroll down to DEF, and scroll up to ABC. Well, so that's so that would be 3 request IDs, and the ABC and DEF would be item IDs. So that's three different request IDs. Yeah, our item. Yeah, okay. Probably make using a single request ID usage more. So like so when you do scroll up and down on Facebook and stuff, that is actually a single page application. And it like has ongoing requests like as you're scrolling around and stuff. So like for example with TikTok, where it has like that feed and you're just continuously scroll down, every single time that you like scroll down by one video, it sends a new request to the backend, or it at least logs it on your device and like aggregates up all those requests before it sends it over to the server. But it is logging each individual interaction, and so it might it's either going to aggregate it up on your device, but more than likely it might be doing each of those individually. And that's a whole thing that I could get into, but I'm gonna leave it at that. Yeah, I think it is multiple requests though, and depending on whether or not you want to make them idempotent, it would be one variation versus the other. It's like it depends on if you're going to make it idempotent. But again, also you can batch up those view things into one thing that you just periodically like kind of pull with. Post ID plus user ID key, won't it suffice for handling duplicates? Well, so post ID is the item ID from my problem, and then user ID. So it's like, what if a user has multiple requests for the same item ID? So that's for example with the inventory problem, the Amazon inventory problem. What if somebody has two items in their cart? Or if they've viewed a video, if they're on YouTube and they view a video multiple times, that's actually a thing in the analytics, is how many times a user has on average reviewed a specific video. So if it's like one of those viral ones that are like really well made that you and your friends might see and like laugh about, like sometimes you do like rewatch old videos that are nostalgic or something. So like it might make sense to actually record the same post ID multiple times sometimes. But if you're just doing like unique viewer counting, yeah, you're probably fine to do that. And you can just go ahead and like have that as the request ID itself. But for unique viewer counting, there. I think that's a good way to explain that one. Latency for GET request on BigQuery likes. Yeah, it is. Yep, it is. That's why I said that it's a thing you need to consider is latency is a thing for variations. Trino actually runs shockingly fast. It does actually run shockingly fast, but so when you're doing a thing like this, typically it would be in the context of a bigger system. I'll go ahead and draw this out. So more than likely, most of the time you would have that, and then instead you would actually have you would like cache it in some kind of backend service. So you'd have a service-oriented architecture, you would like have this like thing run every so often, and then you would have your own cached database. So this would be like downstream data. Sorry, I'm scrolled out, like I'm way zoomed out right now. So you have some kind of like downstream data store, and you like stick it over there. and then you would have something like Redis or something. So a good example of this is like the Spotify top K problem. If you're not doing rolling windows, you would, for example, do something kind of like this. Or if you're doing like YouTube view counts, for example, great. I appreciate that you pointed this out, by the way. It's yeah, that's like why it's a whole thing that I wanted to get into with these things. It could be like a YouTube view counter, um periodically updated. You want high accuracy. um you want high accuracy, but it can be eventually consistent. And so like the number is going to trail behind, or you could even do some kind of thing where you're combining the pre-aggregated results with a count min sketch thing. So then it's going to be like off by a little bit. So you can also do, or periodic aggregations plus count min sketch results is like one way to kind of do it. So I'm gonna stick that in there in variations. This is I don't know if I actually have anything recorded anywhere on doing something kind of like this. So it'd be kind of nice to have it in the approaches section. We can call that 12 YouTube view counter. Yeah. But yeah, so it's usually going to be in the context of some kind of other system where it's like Redis, and you got this like YouTube video metadata. So you have like the YouTube video metadata, for example, on a video that you're pulling up. And so you could say that a video record might look a little bit like this. We got this like video ID of this weird key match crap from the URL. And then you got the S3 or CDN 3 or CDN link for the actual object file. S3.aws P3 file, and then you would have the counter, view count. Say like 6 million or something. So you can have it like pre-aggregated like that. And then of course you have some kind of other thing for actually like the video retrieval service or something. Where you're like pulling up the description, and then you would actually have like the user viewing a video. And then you got the request comes in, you pull in the data, you've got the pre-aggregated count, and then you have a response back. It looks a little bit goofy because you've got like all these hops between them, but sometimes you want to do further analysis somewhere else on the individual requests. And so you just have this like big request table back in the data warehouse, and then you might have your counts aggregated off of it and just cached or something. Great question, though. That was very interesting. Okay, I think we're good to move on to approach 4 or something. We just did 3. Let's check out. Maybe this was what the heck I meant by 4. Or oh no. Okay, so this one was missing timestamps. We don't have timestamps in our counter table, so we can't actually do yeah, we don't have timestamps in there. I think we would still need our item ID in there. Yeah, so we're going to take our OLAP thing from here and we're going to use it for making rolling windows now. So we're just taking approach 3 and now we want rolling windows, but we're not using count min sketch for it because we want accurate counts. I should make a note of like what the heck I'm saying to justify this. So it's turning 3 approach 3 into rolling window. And so what this exact counts, while with count min sketch we don't care about exact counts. So that's the distinguishing thing here. Yeah, so with 4 we still want our exact counts. How are we going to do it? We would still need to have a timestamp. I think we could go ahead and get that on the backend services instead. So we would go ahead and have that populated over here. It doesn't really matter. It's just a trade-off and it depends on what your use case is. But your timestamp could either come from the backend or it could come from 136.0.0.0 5,000. I think that's a good Unix epoch timestamp I use a lot. But it's more standard, I think, to have it come from the back end than the front end, because the front end you can always have the users manipulating the timestamp that they hand over just manually, and then you're going to have that timestamp in the request table, and then that's how you can get a rolling window. I would say that this is like more of a thing for top K problem, for example, might do this. So like Spotify top K songs, for example. Or even if you did have rolling window, you could, so for example, you could rerun a request for the last hour every 5 minutes. Yeah, but it's where you care about exact counts for some reason. And but you care about exact counts, but you're not doing it like real time, or you're caching them. But yeah, so I think this is probably what I was thinking about. Oh, and then so this is actually where you would probably have something that looks kind of like this. This might have actually been what I was thinking about for approach 3. I don't know what, but we've got them recorded now, I think, and they'll be in the text files that we've got both of these approaches here. All right, so we've covered that. I think this is approach 4. I did cover the YouTube view counter. Below approach 3 and the diagram file there. I mentioned that do count min sketch plus aggregated exact counts for, yeah, cool. All right, I'm happy with that. All right, let's go through some of the questions in the chat. Why didn't that copy? How we will do exact count and approach 4. We have, it's deduplicated. We have the request ID deduplicated. And then for whatever reason, you want to see an exact count of like for the past hour. So you just do, here, let me kind of write out the query is that you would have select, you do some kind of count of unique request ID where item ID equals 456 and timestamp is greater than so it looked kind of like that. And so then that would get the exact count for an item ID over the past hour. So it'd be eventually consistent, but you would still get exact counts. So if you have something really faulty, it would not be prone to double counts or undercounting or anything like that. You can get exact counts. Or for example, like what if your updates are at your items getting counted at a very low rate, but you have so many items that still results in a really high write volume? That could be another example where it might make sense. And if you're starting over the item ID and you're using Cassandra, you might even be able to use a key range query for this against Cassandra or something else where you just use the partitioning key. And then you wouldn't even really need to do OLAP. Yeah, so it might even be kind of applicable for like non-OLAP cases. Yeah. Okay, let's look at the chat. What about CRDT that implements a should counter over a? I have that in there. That's another one we're going to get to. I'll take this as a sign we should go ahead and move on to, I have, so Redis is approach 6. Yeah, that one's approach 6. Let's go ahead and do approach 5 really quick and approach 6. And then I'll go ahead and look at the chat again. So I'm going to do approach 5. We have 5. And so like we could actually even have those counters like stay off to the side. We could even still have it over there. We would have our task runner. So you could still do something like that if you wanted. But key part is that we're going to have this special component called Flink or Firehose. And that I think is going to be doing some pulls off of Kafka. And then we've got this thing that is just going to be hitting Flink or Firehose directly. That's how I believe that works. There, so that is approach 5. And then this is optional. It's not actually necessary for the counting. It's just like an example of like other things I've done in other designs. Okay, and now we're going to do 6, which is the Redis one. So the Redis one is going to look the most like this, I think, is probably what it's going to look like. For Redis CRDTs, you got these counter data stores, you have the item ID, and it is leaderless. So you'd have it like replicated on multiple machines, and you just have the count. It's a grow only counter. And I think that's all I really have to verify about. Well, so you wouldn't actually partition it off the item ID. I guess you wouldn't do that. It's a primary key. And I guess you can do like multiple replicas, and you'd have these little groups for specific key ranges. but you're not actually petitioning by the item ID itself per se. Yeah, you would just route the write to any of these things. They somehow sync up with each other, and then you get a count, and it's non-item potent. For 7, oh, I know how I'm going to do 7. I know I'm going to illustrate it. Yeah. So, anyways, here's Redis. What's bad about this is that if you do a request, it might drop it midway on the way back to the client after successfully counting, and then the client's gonna be like, I wonder if it actually counted. And then it'll retry the request and count it again, and then send it back to the client, and then it gets the 200 okay. So they stop then, and they stop retrying finally. You might be saying like, well, why don't they just not retry? Well, it's because you could also have on the way from the backend service to the database, you might get a 404. You might get a drop between, you might get it on the request side. You might drop the request, and then you would return the 40x or 50x to the client, and then it's like, well, then it didn't successfully count. It's communicating it properly. You can't tell if it's on the request side or the response side where you're getting the dropped packet for the network. So this is CRDTs fix the issue of write conflicts. They do not solve the issue of item potency. And Martin Kleppmann's even gone over this himself in one of his videos. But there is actually a CRDT, an alternative one that does slightly approach this. I don't know if it fully fixes it. It's called a forgetful bloom filter. I'll show that in approach 7. There's nothing that has it implemented on its own, but you could possibly roll it yourself. And so you would need one of the databases that allows for rolling your own write conflict resolution. I think you would have a request ID in it. So you would have something that looks like this instead of just the item ID. So with approach 6, you would have just the item ID. You don't have the request ID, so it's going to look like that for the request. While over here, we do have the request ID in there. And now we want a forgetful bloom filter. And we need any DB that allows you to roll your own write conflict resolution logic. And so that usually is one that has causal consistency. And so what we have is Cosmos DB allows you to do that. Maybe Reoc. Who else lets you do that? I don't know. It's a little bit rare. It's a little bit unusual to have that as an option. But if you don't have it, it just does last write wins, and then you don't have your write conflict resolution. And then you would somehow use that in the little bloom filter thing that you roll yourself for the forgetful bloom filter implementation. That's how you would do this. All right, well, I've just thrown a lot at you guys. I'm going to look through the chat again. So that's approach 6. Whenever the chat starts to get ahead of me, ahead of themselves a little bit, it's like, okay, maybe I should zoom on with a couple more approaches. That, yeah, I believe that was what Sarov was getting at, is approach 6. I think. Why P2P? Is that like gossiping? They might actually do gossiping. P2P stuff is add-on. We need to implement a type of counter, which is called a grow only counter. So yeah, I did specify that grow only counter with a way of storing and synchronizing the counter value from other agents. Yeah, I think I nailed it. Let me know if I didn't. Ignore the P2P term. Isn't that just a Redis CRDT? I believe so. It's the gossiping is probably peer-to-peer on the CRDT side. It's leaderless. So I think the peer-to-peer term is probably leaderless, is probably what he's specifying. There, 1 2 that it's a thing in leaderless systems, and it's probably gossiping under the hood. Can this be done in any programming language? That is a good question. It depends on what they allow you to implement it in for the DB. Their right conflict resolution. Solution. So Cosmos DB actually requires Lua, I think. Oh, I had my phone muted. There. Oh, no. There we go. Got it. Yep. All right. Yeah, I'm pretty sure Cosmos DB requires Lua. I don't know what the other ones require. I thought that React uses Erlang. Some of them might actually allow JavaScript for the language or something. It's weird. It depends on what they support, though. Yes, either implement your own or use Redis CRDT. The CRDT part is straightforward. I'm curious about the P2P part. This works better when you are leaderless and hence P2P. Yes, leaderless. Yeah, it's so hard to follow all these terms. I do it I think I still don't know the difference between version vectors and what is it, vector clocks and version vectors. It's so easy to mix those up. The terminology is kind of hard to follow sometimes. And then also there's like 3 different terms for leaderless. It's also active, or there's also what's it called, multi-master. From back when it was called master slave. You're not really allowed to say that anymore. So like master, multi-master, active, leaderless, they're all the same. It's kind of, yeah, I can see why you use the term peer-to-peer there. It makes sense. Okay, so we have done approach 7. All right, what's next? Oh yes, the sharded counter on its own. So this is just if you have a super hotkey. So we're going through super hotkey approaches right now, which is where you now have to have multiple different nodes that can accept writes. And so for the leaderless ones, it's just as a consequence of how they're set up in a ridiculous way, but you cannot get accurate counts here. So can't handle exact counts. Might not be able to handle. It probably isn't. And grow only counters on their own. This one is also not idempotent, but like some of your databases just straight up don't support CRDTs. So like DynamoDB is an example of this. DynamoDB is single leader, and although it's eventually consistent, it's like it's single leader. It doesn't have CRDTs. You can't do CRDTs on a single leader approach. It requires multiple. So you have to set up like the multi-leader thing yourself. And so it's almost like some keys are multi-leader while other ones are single leader. And so such as DynamoDB. Yeah. So this is a case where you would maybe want to do that, and then you can't do 2 tables on one machine on DynamoDB, and so then you can't do DynamoDB on approach 9, which is really fascinating. So it's like there's some really fascinating edge cases when you're trying to improve the accuracy, or like when you're just stuck on certain approaches. 8 would really be like Amazon specific scenario, because like at Amazon, you're specifically going to use DynamoDB basically everywhere because it's pushed top down in a similar way to how Spanner's push top down at Google, or I don't remember other companies, but yeah, so it's specifically at Amazon. You might end up having to do 8 in certain really rare situations. So let's show that. I think I can just reuse this diagram. So yeah, we've got approach 8. So we got a request coming in. You still have that. And I think you would just go ahead and have so this would be I gotta zoom in, sorry. Okay, so we have that, and then we have a shard ID. And we could have it as like 2 and range like 1 through 5, for example. And what we would do is I think we would just have the backend service randomly generate an int between 1 through 5. So I'm going to have that, and we're going to say randomly generates int in a range such as 1 through 5. And then when you're doing your write, it would be like insert your record. And it's so you would have a 4, 5, 6, 2, 5, 6, 7, 8. I don't know. I haven't done a insert statement in so long. I'm so used to writing the select statements. I don't actually remember what the syntax is for this. It would look something like this. I think you guys get the idea. And so then what about how did I communicate this in the other thing? I said partitioning key. Yeah, it's partitioning key and primary key. So that's what we're doing here. And we got our shard ID 2, 1 through 5. So range. And that would also be part of the partitioning key. Partitioning key, we've got 2 parts to it, and the primary key comes over both. And got the count. And then you would, of course, need to do a key range query now in order to find the shard ID. You would need to do a key range query to get the total count. So let's say we have, I'll draw some of the other records. So we have 3, and then this other one has like 6, 7, 8, 2. So we would need to get all 5 of the shards. Let's kill that. And then let's show what our select statement looks like. It's like select all from table where item ID equals 4, 5, 6. Yeah. So then it would pull up all the machines that have the shards 1 through 5. So it'd be up to 5 machines that would be impacted by that key range query. But you might have like 50 machines overall or something. Or like so, but like Discord, for example, has 70 machines for running Scala. So you might have something like that. So that's why it's not, that's why we don't have that scatter gather issue that somebody else had asked about like much earlier. That's how this is kind of distinguishes that we still do have at least part of the partition key. And so it still really narrows it down, as opposed to if we just had, if we didn't include item ID at all as a partitioning key somehow, that would of course then mean it would be that would really make it scatter gather. I have seen this get screwed up in implementation before, where somebody like gives it like a range of 1 through 100, but like it's clearly not using 100 machines, and so it does actually do a scatter gather on those. You can also like optionally do only some. You could also have a shard ID of null, and then it would only go to one machine. I think it would be able to route it properly since it's part of the partitioning key. And yeah, so there's ways to like optionally make a scatter gather occur. So you could even turn some keys into completely leaderless if you just like oversize the shard ID range, and then you just have other ones that are left as null. So I could even specify as that you could have 1 through 5 or null if you're doing that. And so then if it's null, if it's one of those, but then you would also have to know which of the item IDs are leaderless and which ones are not on the back end. And you could maybe use like a Redis cache or something that's co-deployed. What's that called? Sidecar. You could do a sidecar Redis deployment in order to figure out if a given ID is sharded or not. Even have different ranges and also store that as the sidecar deployment on the right backend service. Yeah, so that's approach 8 though. It's the sharded counter, but you don't have it idempotent still. It just allows you to scale up super hotkeys. Yes. Looking at the questions, how both item and shard ID will be used as partition key. Well, you're able to do that. You're able to do that. DynamoDB allows you to use multiple attributes as a partition key. Yeah, and in Cassandra, it actually just makes a concatenated index off of all of your sort key and partition key choices, and then it like uses the first however many bits as the partitioning key and the last however many as the sort key. But in DynamoDB, it's like a lot more specific about how it works. It's yeah, you're able to do this though. Okay, so we did approach 8. So what if you do a proper sharded counter with idempotency? So 8 is non-idempotent, and then 9 is actually idempotent. So 8 usually does not make sense. It's a non-idempotent. It's just very rare cases where you like strictly get stuck into that. And we would use manually sharded PostgreSQL here. Okay, let's go ahead and copy paste it over. And now I need the thing from approach 1B. We have in the request, let's delete this, that, have our request ID again, which is like DEF ABC 1 2 3 DEF ABC. Okay, request ID, item ID. Okay, and we're doing same kind of table setup as from 1B, except now it's sharded. You need to add the item ID in the request table as well. Yeah. Because it needs to be sharded just like the counter table. So you'd be sharding these both. And oh, you also need a shard ID though. So you would use the request ID for determining the shard ID. you'd use the request ID for determining the shard ID. That's how it would figure out which one it's in. Got item ID, request ID. Do we need shard ID itself necessarily though? I don't know if we necessarily actually need the shard ID in this thing. Because like we're doing it manually. I haven't really done manual shard. I've never done manual sharding before. It's like really hard to do it. Um, and you actually have to like query the tables individually is another part of the issue. So, I can at least like record it and like mark that I think it's optional. Multiple machines would have the exact same record slash primary key. Yeah, I don't have like any experience with doing hands-on manual partition, but I'm fairly sure you might be able to get away with just not having that in there. Since it's a function of the request ID, you would be able to determine which machine it is off that. All right, I think we can move on. I've done this approach multiple times before, like with flash sale and stuff. So I think this isn't anything crazy or new, and we know what that one is about. Yes, this one. Request table, and you can just do event sourcing. So I didn't cover the Cassandra approach. I covered the OLAP 1 and 3, but I didn't do like Cassandra actually has MapReduce built in. I don't know if that's actually a good idea. But yeah, so let's go ahead and cover that with I can go ahead and use this. All right, we're gonna do this. It's approach 10. You have the request ID and an item ID. You don't need the timestamp. And instead, we're just gonna have it right there. And you've got your counter data store. It's going to be Cassandra. Got this. And then you can do a MapReduce query against it. Cassandra has built-in integrations for MapReduce. I don't know if that actually makes it a good idea to do that, but it is an option. And somehow you can have that just run straight off of backend service. So in an actual system, you'd probably have some other backend service, and it would just be aggregating it and putting it into something else, some other data store. So you would not actually have it go right straight to the browser. You would have it like cached somewhere else. But this is kind of like abstractly how it might kind of work. Okay. Oh, I didn't go over the schema. We have the request table, item ID, request ID. You just kind of partition it by the item ID is the machine key. And again, what we have here is Sandra. Okay, that is approach 10. So it's pretty similar to 3. Yeah, I think I was just kind of going for, I think I did just in my notes forget that I'd even managed to cover it. Oh, no, this is when it's, with 3, it might've been on 1 machine. I don't know. I think we can move on. Oh, there's whatever I did in my inventory video. Okay. Yeah, I can cover this a little bit. That'll be our last approach because we've already gone over 12. That was just drawn below approach 3. Before we jump into 11, which is going to be weird looking, I will check for any questions in the live chat. Looks like we already went through everything in the Zoom chat. Your guys' ability is not important here, so we can tune up the availability with leaderless. Let's link to the doc and side. That'll be at the end. Yeah, I'm going to do that at the end. Don't worry. I've done that for like the last 2 months, I think. So I'm going to keep up that trend. I won't. Yeah, it'll be there. Don't worry. Even though we are using item ID as partition key, it would still hit all the shard IDs. Though we're using item ID as partition key, I think that was, it was for approach 8. Okay. Thank you for clarifying. This one was sharded counter on its own, non-item potent. Well, so it's so you specify the item ID, which is part of the partitioning key. So I guess it might still be considered scatter gather, but the key is that it's filtered down to a subset of the machines, which is why I don't really think of it quite as much as the same thing. Scatter gather, I usually think of Elasticsearch or something that uses hash partitioning, and so it like scales fine for the writes, but then like on the reads, you literally have to hit every single partition. And so you would actually hit all 70 machines is what I usually think of with the term scatter gather, but that's maybe not right. Scatter gather might just mean whenever you have to hit multiple machines. But like scatter gather usually has this connotation in my head where it's like, oh, you're going to be hosting every single machine. So this is you want to really make sure that your read volume is low. While in this case, since we have at least part of the partitioning key, it would actually be able to scale just fine, unlike the cases where you don't have any of the partitioning key in the query. So like, for example, if you were trying to like find all the records that have a count of exactly 5678, that's not part of the partitioning key. And so you actually end up having to like look through every single data, every single machine to find it. Or if it was part of the sort key, even if it was part of the sort key, like on each individual machine, it would still be logged of in, but the key there is that you're hitting all the machines. So if you have a read volume of higher than like 10,000, it's not going to be performant at all. There'd be like no machine count that would allow you to scale it all the way up if you're doing something like that. So it's just that's might be correct as a term, but does actually scale in the manner that we need. I had a little video about this I have like a little 2-minute long video specifically about partitioning keys or something. I actually spent like 10 hours making that or something wild like that because it was my most cleaned up video ever. And it's also one of my least popular ones. But yeah, I have a video all about scatter gather being an issue, and like we don't have the same issue as what I described in that video, specifically because we are still hitting at least part of the partitioning key. Yeah. Reduce search space scatter gather. I like it. Yeah, that might be, yeah. As long as we're not hitting every single machine, we're fine with doing this. Even if the scatter gather term applies, as long as you're not having to hit every single machine, it'll scale a lot better. BP is just brute force with cache. Oh, that's, yeah, okay. Let's go ahead and move on. I've answered all the questions. Let's go ahead and cover our last approach. I did 10. So with DynamoDB, the issue is that it's NoSQL, and so you can't actually do multiple tables on the same machine. You're not able to like specify it like that. So we're going to take this one and when is this actually a good idea? So you don't have the request ID table, and so like for when you want an exact count, I guess this one isn't with super hotkeys. This might not actually be a super hotkey approach, although there's a way to make it yeah, so it's not actually specifically about that, but you can make it work like that. So you've got the item ID. You do still have a request ID in this case. This was a really weird design that I made for that problem. So you've got the counter IDs and you still want to make them idempotent, but you're using DynamoDB is the scenario here. So it's like really Amazon specific. Have DynamoDB, but you still want exact counts. That's the specific scenario that we're designing for. So we have the item ID. We don't necessarily need to have a shard ID in this one. We just have the counter table. It's DynamoDB. We have this request ID that comes in. We don't need to clarify that. That one's kind of obvious. You would have this like it's like request ID list thing, and you could have DynamoDB is a document store. So you can have these like nested attributes like this. So you would have a request ID. See. Then it's like, how do you can do this like later cleanup thing. So when you first write it, you stick the request ID on that item ID. So this is how you like make it idempotent. And you'd also increment the count while adding that to the list. And then I think you need, I had something involving a status. Maybe you'd have like this DB trigger where you would specify if it was flat. Oh, you would maybe have a request table. You would maybe have this entirely separate request table where you're tracking if it's received or not. So I think you have this like request data store. Somehow involved, and then it had would map a request ID to the status, which would be received. Okay, I think you would have this thing first. It'd be the first thing that you write to, and you might use a DB trigger or something. I did some kind of weird crap with two-phase commit. I think, yeah, I think this involved like two-phase commit. And so you would do, you would lock both the records on both the tables. This was totally weird. So you'd first lock the records on both the tables and update them both with two-phase commit. And then after you committed them, you would have this cleanup worker that would also come by every so often. Or could even use like a DB trigger or something like that. We call it clean up task workers. And then it would look at the request IDs, and it would go over here and it would delete those request IDs from the list. Or I think this would maybe on the right, you would just capture the request ID without incrementing the count. And then later during the cleanup, you would go ahead and delete it from the request ID list and increment the count over there. But I had that. The issue is that like if you don't have the cleanup worker, the request ID list would become thousands of different requests because you're combining them both by denormalizing the request table into the counter table a little bit for making the item potency happen. But then you also need to like clean up the request ID list and eventually like delete all those request IDs, otherwise it would become thousands. And so then you have this other thing over here. It was really wacky. It was an innovative idea. That's how I'll call it. It was an innovative idea, and I didn't understand sharded counters well enough at that point. But it was something like this. I'm sure there's some kind of application where this makes sense. So if it's low volume, if it's a low volume counter, like you wouldn't have a count in the thousands. It feels something like 56 over the course of like several days. Well, and then also if it's 56, you'd only have 56 different items in the request. Maybe if we'll say like it was just like 8 or like 12, you just have like 12 counts for an item. So if it's like an unpopular product in e-commerce or something like that, it might make sense. I did something that looked like this for the inventory problem. So, and so this is another way to do it. I'm happy you like this approach because I used to think this was really cool, but now I think it's really wacky and weird. It definitely works. It definitely does its job. I think I have actually seen something like this done before at Amazon for like shopping carts. Your cart, you would have like a cart ID instead of an item ID. And then you would add stuff to cart and it would do something kind of like this for building up the order. Yeah, I think they did something like this for inventory for making shopping carts, though. I'm fairly certain they like legitimately had two-phase commit working in some kind of inventory service. they literally had two-phase commit. They were doing something that looked a little bit like this. Yeah, maybe it's cleaner than this, but it works. It definitely does intuitively make sense, and you would actually get exact counts. But it's just like such a weird way to like look at the problem. I definitely wanted to cover it though, just because we're trying to cover all approaches for each problem and being more open-minded. I really like to be open-minded with these problems, and like it works. So here it is. Okay, are there any other questions? Otherwise, I think we might be good to wrap this up, and I'll of course post the files afterwards. Reading through the comments. I think I did cover all the questions. Sweet. All right. I think we're good to go ahead and drop off then. Thanks a ton for joining me. I really appreciate it. I hope you guys learned something. So that's all. Yeah. Thanks again. See you guys.